Good morning everyone. This is G. Om Kedareshwar Kiran from Institute of Aeronautical Engineering from Department of Electrical and Electronics Engineering. Today's topic is about homogeneous equations in data science. Homogeneous equations in data science. Homogeneous equations are a fundamental concept in linear algebra with wide-ranging application in data science. They play a crucial role in areas such as dimensionality reduction, clustering, a regression analysis enabling data scientists such to uncover hidden patterns to extract visual insights to complex data sets. Definition and properties of homogeneous equations in data science. Homogeneous equations are a special type of linear equations where the constant term is zero. They describe the relation between variables in a system, allowing data scientists to model and analysis with underlying structure of their data. To describe the relationship between variables in a system, they allow the data scientist to model analysis a underlying structure in data. Understanding the properties of homogeneous equations is essential for developing effective data analysis techniques. To improve the data analysis techniques, the homogeneous of properties in equations is essential for development of the data analysis techniques. Applications in data science. There are visual applications in data science are as follows. Homogeneous equations have numerous applications in data science, including principal component analysis (PCA) of dimensionality reduction, linear discriminant analysis (LDA) for classification, a spectral clustering of unsupervised learning. These techniques leverage the properties of homogeneous equations to extract meaningful information from high-dimensional data, enabling more accurate and efficient data-driven discussion-making. The LDA and PCA components are main application of the data science in homogeneous equations. Solving homogeneous equations. Before solving the homogeneous equations, we can see the picture of solving the strategies. Now we make a list of the solving the strategies and work backward, write a number in a sentence by using an object. So solving an homogeneous equation classifies that data scientists often need to solve homogeneous equations to uncover the underlying relationship in the data. Various methods such Gaussian elimination of matrix decomposition can be used to find the solution of these equations. Mastering these technologies is crucial for developing sophisticated data analysis pipelines and making informed decisions based on the insights derived in the data. Eigenvalues and eigenvectors. The eigenvalues are scalar values to describe the scaling factors of eigenvectors, which are the non-zero solutions of homogeneous equations. Eigenvectors applications. Eigenvectors are the direction which the linear transformation acts by simply scaling the vector without changing its direction. Eigenvalues and eigenvectors are essential for tasks like principal component analysis, image recognition, and image recommendation systems. These eigenvalues and eigenvectors are very essential applications for the homogeneous equations. The only eigenvalues are non-zero solutions have homogeneous equations. Dimensionality reduction techniques. Principal component analysis (PCA). PCA, the principal component analysis, is a popular dimensionality reduction technique that uses homogeneous equation to identify the most important feature in high-dimensional data. The PCA uses the homogeneous equation for the most feature high-dimensional data in the dimensionality reduction. The second one is linear discriminative analysis. LDA, linear discriminative analysis. The linear discriminative analysis (LDA) is a supervised dimensionality reduction technique that leverages homogeneous equations to find the linear combinations of features that best separate different classes. Singular value decomposition (SVD). SVD, singular value decomposition, is a matrix factorization technique that can be used to solve homogeneous equations and reduce the dimensionality of data. The dimensional reduction techniques are of three types: PCA, LDA, SVD. PCA stands for principal component analysis, LDA stands for linear discriminative analysis, SVD stands for singular value decomposition. These are the three dimensionality reduction techniques. Clustering and classification. The clustering and classification are of three types. K means clustering. K means clustering use homogeneous equation for a group of data points into K cluster based on their similarity. Spectral clustering. The second one is the spectral clustering. The spectral clustering leverages the eigenvalues and eigenvectors of homogeneous equation to identify clusters in complex, non-complex data. Linear discriminant analysis (LDA). The linear discriminant analysis (LDA) can also be used for classification tasks, finding the linear combination of features that best separate different classes. These are the three types of splitting and classification: clustering, 3 K-means clustering, spectral clustering, linear discriminant. Conclusion and future directions. Emerging trends. Homogeneous equations will continue to play a pivotal role in development of the advanced data science techniques such as deep learning and quantum computing. The quantum computing is dependent upon the homogeneous equations in emerging trends of development portal role development of advanced data science techniques in such as learning and quantum computing is known as emerging trends. Research opportunities. There are many research opportunities in future directions. The future directions exploring new application and innovation in solving homogeneous equations will open up exciting research advantages in the field of data science. The field of data science is totally dependent upon the research opportunities for the exploring of new application and innovation during the solving in homogeneous equations for the research purpose and field of data science. The field of data science is totally dependent upon the emerging trends. The third one is educational implications. A strong educational implication understanding of homogeneous equations is crucial of data science education as the underpins in fundamental techniques used in the field. The field use the underment sentimental techniques for the homogeneous equations for crucial data science education and underpins many fundamental techniques used in the field. The field uses the emerging trends, research opportunities, and fielding in educational implications. These three are dependent upon the future directions. So this is the conclusion of the homogeneous equations in data science. Thank you.